First of all, I'll be talking about the conceptual point of view, and then we'll be moving on and writing the code for it. I feel like it's important to understand how this works before actually doing it. So basically, when we're reversing a linked list, what we want to do is we want to change the pointers or the next values of each node to point at the previous node. So this is a singly linked list, so we don't have access to pointers to the previous node, just pointers going forward, as you can see in this diagram. So basically, what we're trying to do here, um, when we're reversing a linked list, is to change these pointers. Like for example, for the first node, we want to get rid of this and change it to the previous value. So in this case, it will be no. And then we want to also get rid of this, and we want to change the previous node to point to the previous. We want to change the previous value to point to the previous node, and so on. We want to get rid of this, and we change this to point at the previous node, and so on. And basically, normally in linked lists, the way we traverse through them is we have a pointer called current that points at the first node or points at whatever head points at in the beginning. And what happens is we iterate through with a while loop until current is null, and then we break out of the while loop. But in this case, when we change the next pointers for certain nodes, we can't really go next anymore. So our cur will be stuck. Um, and this is where multiple pointers come in. So basically what we want to do in this algorithm is we want to create three different pointers. We want a pointer to point at the next node. So for example, here we'd have next that points over here, and we want to have a pointer cur that points at the current node, and then we want to have a pointer prev that points at the previous node. And so on. And this is how we traverse through the list with three pointers. And then that way we can easily update pointers. You'll just see why in a bit. So basically, in the beginning of the code, what we really want to do is we want to declare the three pointers. So first of all, we want to set cur to be head because that's what we have over here. So we can go, we can create the node. So we get node cur is equal to head. Okay, and now what we have is what we did here is we have our cur node pointing at head right here. I already drew that. And then what we also want to do is we want to create our next and previous pointers. So we can also go node next is equal to, we'll keep it null for now. We'll change this in the loop. And then we also want to create previous. So node prev is equal to null as well. So previous is already at the right value because previous is supposed to start off at null anyway. But for next, we'll do it inside the while loop. So once we have our declarations in, we can go ahead and head into the while loop. So we want to loop until current is not null, right? So once our cur is a null, once it reaches the end and when it's null, then we want to break out of the loop. So we can go while cur is not equal to null. So as long as this is true, what we want to do first of all is we want to assign next to its correct position, right? So we can just go next is equal to cur dot next. So now what we've done here is I already drew it for you. So this is where we put next. So next is pointing at this node now, and after that, what we want to do is we want to set the pointer for current. So the current's next pointer is pointing at 2 right now, but we want to change it to point at the previous node because previous points at the previous node. So we want to go cur dot next is equal to prev. And what we've done here is basically what we will do is we get rid of the pointer that points to the next node and we point to the previous node. So now what we're having is cur's next is actually no, which is exactly what we want. And now this is where the three pointers come in handy. Now we can traverse through the list without actually losing nodes like we would without the other pointers. So basically we want to move these nodes forward into our list. So first of all, before updating, so like usually we could go cur cur is equal to next, and now cur would point over here, but that's not what we want to do so far. Well, that's not what we want to do right away. First of all, we want to move previous to point at cur, then we want to move to point at whatever cur is pointing at, then we want to move cur to point at whatever next pointing at. We want to do previous first because when we do cur first, then we can't change prev to point at whatever cur was pointing at before. So we can't change prev to point at the previous node. So basically now prev points at the previous node, So to make it do that, we just want to go prev is equal to cur. And now what happens is previous points at whatever current was pointing at. So we can move this. Okay, so we can move this pointer, and this points over here now, whatever cur was previously pointing at. And then after that, now we can move cur because now we already saved the position of the previous node. And now we can go cur is equal to next. And now what we've done here is this cur pointer now points at whatever next was pointing at. And now basically we can see that when this loop comes back and re-loops, we can see that next gets changed to the next value. So we don't really need to change anything right now. All we have to do is just end the loop, and this is our code. We're done. Like at the end, if we're returning, then we can just return. We can return the head of the list, which is normally what they do in linked lists. And yeah, so basically now we've switched the first node. It's gonna go back. Is gonna go back into the loop, and it's gonna loop again. So now it's gonna set next to be cur.next. So cur is right here, right? So next is gonna point at the cur is next. It's gonna come here, and then after that, it's gonna set cur next to be prev. So now this pointer is gonna be gone, and it's gonna point at whatever prev is pointing at. So it's gonna point before, and then we set prev to be cur. So prev jumps up, and then we set cur to be next. So next cur jumps up, and then so on, and we just keep going until we change all our nodes. And so that's how we do it conceptually. So now so I basically wrote the code here. Let's just implement this code onto this website and see if we got it right. So first of all, we can node cur is equal to head. So this is the first thing we declare. We declare cur and we set it to point at head. We're given head in this function, so this is the head of the list basically, which is right here. And now what we want to do is we want to do next and prev. So we can node next is equal to null, and node prev is also equal to null. Okay, and now once we do these, we can just jump into the while loop. So we can just go while cur is not equal to null. So this is basically looping until cur is null. And in this loop, what we want to do is basically what we did on paper is next is equal to cur, next is equal to cur dot next, and then current dot next is equal to prev. And now what we've done here is we set next to be the node after current, and then we set the next of current. So basically what we do here is we save the position of the next node so that we can move current to it later on, because here we're updating the next of current, and the only way to be able to move forward to it is to save the position so we can jump to it later on. So now we change the next to be the previous node, and now what we want to do first of all is we want to set prev to be the current node. So this is now the process. I I'll link them in separate paragraphs. So basically now prev to be current, and then current is equal to next. And basically what we've done here is now we're done our code basically. One thing I forgot in my note over here is to set the new head to be prev, because now at the end of the code, prev is gonna point at the last element. Prev is gonna be right here, and null, and current is going to be here, which is going to null, and then next is going to be after current. So current is null, previous is the last element, and we want to set the head. We want to set the head to be the last element. So basically what we want to do is we want to move this head all the way to the last element. And basically we do that by this line of code right here. Head is equal to prev, close that with semicolon, and then we can return the head because they're expecting us to return a node. And boom. So let's see if this works. Okay, so basically, the input we're given is linked list 1, 2, 3, 4, 5, 6, just like the example I've shown over here. And the reverse version should be 6, 5, 4, 3, 2, 1. And this is basically all we have over here. So now once we're sure this works, let's submit and make sure it works for all the test cases. And there we go. So this worked, and there's an execution time of 2 seconds, which is fairly efficient. You should always keep an eye on the execution time because that's an important part of programming, having efficient code. Yeah, thank you for watching.